Hey guys, so in this video we're going to be going over the solutions for the first problem on our mock assessment, but besides just going over the solution, I also want to talk to you about an equation that we derived from the solutions or the steps that will help you quickly solve any scenario such as this one, which also brings me to the attention that I want to go over different scenarios that you might encounter in problems such as this one. So let's go ahead and start, and we need to begin by conceptually understanding that on this bead of an unknown charge right here in the center, we have two forces acting on it, the force from Q1 and the force from Q2, which in this case are like charges and are both positive. So that means that because they are like charges, our bead is going to end up somewhere in the center of them. And in this case, we've got an insulating rod, so it wouldn't be able to go anywhere outside of them. Um, we're going to begin with the electrostatic force equation, which is the constant K times charge 1 times charge 2 over the distance squared. And in this case, we have two forces, two electrostatic forces, like I mentioned, the one from Q1 and the one from Q2. And what we're going to need to do is we're going to need to set those equal to one another, because when the forces are equal to one another, that means we have no net force. We're going to set up for both of them. And for force 1, which is what we'll call this Q1 on the bead, we've got the constant K times Q1 times the bead, which we'll call B, over the distance, or we'll squared, which we'll call R1, because it's the distance between the origin charge Q1 and the small bead. And then we've got the second electrostatic force, which is going to be Q times Q2 times the bead over R2 squared. And it's important that we call that R2 and we separate that from R1 because they are not the same distance. One is a distance from the origin, like so, and the other is a distance from the second charge, the bead. Now what we need to do is, like I mentioned, we need to have those two forces equal to one another. So we're going to set the equations equal to one another, and that is going to actually allow us to make this equation a lot simpler, because now we can cancel out like terms. The first things that will cancel out are the constants K, and we can actually also cancel out the charge of the bead, which is interesting because the charge on the bead doesn't even matter in this case. It's really more up to the charges on the outside charges that determine where the bead will stand. But the charge on the bead itself is insignificant in this point. That is just the beginning step, so we've canceled those guys out, which leaves us with a much smaller equation. And now we're going to continue by relating Q1 and Q2, and then we'll follow up by relating R1 and R2. Well, Q1 is 4Q. That's given up here in the scenario, where Q1 is equal to 4Q, while Q2 is equal to Q. And that's discussing its charge, but ultimately what it's saying is that Q1 is 4 times the charge of Q2. So what we can do is we can actually take these variables out and actually substitute them with values, and we'll substitute that with 4 and 1, which again leaves us with an even smaller equation. So we're getting there. But now the most important part of this equation of the solutions is to relate R1 and R2. Well, those are two different distances, as we've already discussed. But R1 and R2 are related to one another in that they both equal 4.8 meters. So R1 here and then R2 from over here from Q2, regardless of where one is related, the other one will add up to equal 4.8 meters. So that means that R1 plus R2 is equal to 4.8 meters. And so we can solve for either one of those and substitute it into our equation over here. And we'll go ahead and subtract R1 from both sides. So minus R1, and that leaves us that R2 is equal to 4.8 minus R1. So we just did that by relating by R1 and R2 to each other. And then now we can substitute R2 into our equation over here. So I'm going to go ahead and do that for us real quick. So that's 4.8 minus R1. And then it's very important that you remember to square that. Now we've got the same variable on both sides. And because they are like variables, we're able to now solve for it. And the step that we're going to take next is going to make it a lot easier than trying to FOIL this out and solving for R1 what we're going to do is we're going to take the square root of both sides. Square root of both sides of these fractions. So that means we're going to take the square root of the denominator and the numerator on both sides, and that is going to leave us with the square root of 4 is equal to 2, and then the square root of r1 squared is just r1, and the square root of 1 in this side is 1, and then the square root of 4.8 minus r1 squared is just 4.8 minus r1. So now the next step that we'll take is pretty straightforward. We're going to multiply, we're going to cross multiply and solve for r1. I'm going to let you do that on your own, and we get, in that case, that r1 is equal to 3.2 meters.